G'day chemists. So today we're going to look at a particularly special type of evaporation for separating mixtures. A lot of the times we'll have hydrated salts or ionic crystals that have water embedded into the crystal lattice structure. Now, what makes this really interesting is that we can separate out the water in exactly the same way. We can just evaporate it out, and it'll go straight from that sort of solid locked in to a gas being evaporated out. One of the really common examples is copper sulfate. So, for example, if you're ever at a trivia competition and they ask what color copper sulfate is, as I was at one point, the answer is actually white. Copper sulfate as a solid is, well, in any form, is white. Copper sulfate hydrated with 5 water molecules, so 1 copper sulfate molecule for every 5 water molecules, is blue. But generally, copper sulfate is a white substance. So by the end of this, we want to be able to safely and accurately remove water from a solid crystal. In one way to think about it, one way that we like to talk about it is copper sulfate, but there's lots of different places where we can remove it from. So this is your vocab. If I could just get you to pause the video here and we'll come back to it when we're done. But there's how you've got this to refer to as we move forward throughout the lesson. So evaporation from crystals. Here we'll see copper sulfate in its regular hydrated form, and this is anhydrous copper sulfate. So copper sulfate without any water locked into it. And when we have anhydrous copper sulfate, what we can actually do is we can add water to it, and it goes from this white to this lovely blue straight away. Like, it's a really quick and exothermic reaction. So when water is present in a crystal, we can remove it by evaporation. Now, ionic substances tend to have, such as copper sulfate, tend to have very high melting points. And this means that when the water still evaporates at 100 degrees Celsius, the ionic solid is left behind because it's not even close to high enough to remove that substance. So, our method is very simple. Basically, we're going to put it in an evaporating dish or a crucible, something that can withstand a bit of heat. And we're going to heat it over a Bunsen. So the hydrated copper sulfate in this case is weighed, and that's important if we want to work out how much of it is water. And often you'll have to do this with empirical formulas and stuff like that. So we weigh it first, and then we heat it over a Bunsen burner. So the copper sulfate should change color. It should go from that beautiful blue to a pale blue as the water starts evaporating. And that salt will eventually become a white color. It gets really tough to tell, to eyeball when it's actually finished evaporating, because once it's white, we have the urge to look at it and go, yep, we're done, we're good, but not necessarily. So what we do is we weigh the salt in the crucible or the evaporating basin at regular intervals, every 30 seconds or so. And we do that until we get 3 or 4 weights that are the same. So it stops decreasing. Now this reduces errors caused by the remaining amounts of water. So it will look as though it has become dry, because that's what we call it. It's anhydrous. So it looks as though it's become dry before we actually run, before it is. So it will give that appearance. And if we're doing something which is like, say, a magnesium salt with water, they'll tend to be white. So we can't, and they'll stay white, they'll stay the same color. So we can't always tell. Our equation in this case, so I want you to, draw this, write it down. We've got hydrated copper sulfate, or CuSO4 dot, there's a little period in the middle there, 5 H2Os. And then you could put that in a bracket, a little state of matter solid. And this gets heated up to anhydrous copper sulfate, so you see the water has gone away, and 5 waters. Now that should actually be steam, because these are a vapor, it's a gas molecule, and we go from blue crystals to a white powder. It's still a crystal, it's just a fine powder, that's all, because the water which was binding it together has evaporated out. Now, that's it. Basically, it's that simple. So if you have any questions, put them in the comments below. Subscribe so you can keep up with what we're doing. And yeah, Thanks for watching. Sorry, it's been a while since we've made a chemistry video. Thanks for watching, and we'll catch up with you next time. Bye now.